Also tried things like, Xamarin Forms. But we just weren't really happy with, how easy it was to iterate on platforms like that. And eventually, in fact, Mike, who also works at Hero, had suggested looking into Flutter. And after giving it a shot, I kind of fell in love with it pretty quickly. It turned out to be a really good fit for us, at least, and provided the kind of flexibility that we were needing, but also, as we'll see some of the features as we dive in, it really allowed us to keep really tight feedback loops, and iterate really quickly, which is incredibly important, especially in a startup where the whole goal is to move as fast as possible, right? So let's kind of start by talking about what Flutter actually is. So right here, I'm on the Flutter website, which is flutter.dev. And the first thing we see is this description. Number one, it's a framework from Google, but it's Google's UI toolkit for building beautiful, natively compiled applications for mobile, web, desktop from a single code base. Now, the web and desktop side of this is a really interesting story, but it's not something I'm going to be focusing on tonight, or even probably next month. As far as I know, both the web and desktop versions are still in alpha or beta to some degree, and aren't really considered stable. But the mobile aspect of Flutter has been stable for over a year now, and works really, really well. And it was initially what it was created for. But the other thing I want to talk about really quick is this fact that they call it a UI toolkit, which is actually surprisingly accurate. It's a collection of components in many cases to build really custom looking and really well designed UIs. But it's also a little bit more than that. It's actually somewhat of just a framework, kind of like a React or Vue on the web. It provides a way to think about, the logic of your app in really great ways. And then also, once again, it's also a UI toolkit on top of that. So it's kind of like, if you're familiar with React or Vue, it's like that plus a really great component library to use with it that provides a whole bunch of bells and whistles to make building your app as seamless as possible. The other thing I want to touch on is the fact that they say, you can do all this from a single code base. If you've ever done any native development, you're probably familiar with, the fact that iOS and Android are very different platforms with entirely different programming languages to build for those platforms. But Flutter uses a single language and a single code base to build to both platforms. And the language you write all of your code in with Flutter is Dart. In fact, a large portion of this presentation, we're actually going to be going over kind of the basics of how to use Dart just as a language. And I'll touch why Dart in a few minutes. But just know that Dart is the programming language that Flutter itself is written in, and also what you write your code in as a Flutter developer. The other thing I want to talk about with Flutter is, if you're familiar with any other hybrid mobile app platforms, maybe like React Native or Xamarin Forms, in many cases, those platforms are still rendering native UI. They just have a different way for, some abstractions for you to build on top of that allow you to not have to think about the low-level native, UI classes and whatnot. But what's different about Flutter is that Flutter actually comes with its own rendering engine. So when a Flutter app starts, it's essentially just a blank view that it treats like a canvas and begins painting pixels onto. And the rendering engine it uses is called Skia, S-K-I-A, and it's the same rendering engine that's actually used to power Google Chrome. That does not mean that it is web-based. There is no concept of HTML or CSS or JavaScript in Flutter, but the low-level graphics engine that's used is the same as Chrome, which is a really good thing in my opinion, because Chrome's rendering engine is actually pretty dang good. So if any of this sounds awesome to you, the single code base stuff, the awesome UI toolkit, you might be thinking about maybe the elephant in the room, which is the one thing that seems a little off here, and that's the programming language behind it, Dart. Dart is not at the top of most used programming languages out there by any means. It's a relative newcomer as far as programming languages go. But there's actually some really interesting reasons why Google chose Dart to power Flutter. One, the first one that might come to mind is just the fact that Dart is made by Google as well. So why not dog food their own programming language? But there's also some other really interesting reasons. So So kind of, I have a list of a few of them that make Dart a really good fit for Flutter specifically. One of them is just, if you've ever had the chance to look at any Dart code, you might be surprised at how familiar it looks to other languages like JavaScript or C#. And so because of that, it's really easy to pick up as a second programming language, right? If you're already familiar with some of the more popular ones out there, you'll feel right at home in Dart most of the time. Another thing that I want to mention that makes Dart such a great fit for Flutter and really just a great fit for building user interfaces in the first place is it's asynchronous by default. So just like how JavaScript is single-threaded and event-driven and heavily event-driven, which makes it so that web applications don't jank most of the time when they need to do some background processing. You know, your UI doesn't freeze up when it needs to make a network request. Dart has the same model. So Dart is a single-threaded programming language, but it also has built-in structures for handling, you know, asynchronous tasks and you know, things happening in the background. It also has streams as a first-class citizen, which, you know, if you're familiar with languages like JavaScript, you might have heard of something like observables, which are very, very similar to streams, and that all comes built into the language in the standard library. You don't have to add any additional packages or anything to pull that kind of process into your app. Another great reason that Flutter or Dart is a great language for Flutter is this part that you talk about right here, natively compiled. And that's because the Dart compiler actually compiles into native machine code. It isn't an interpreted language like JavaScript is. It's compiled directly into native machine code, which they call AOT compilation or ahead of time compilation. But Dart also has another side. It has a built-in JIT compiler, which stands for just-in-time compilation. And what that allows is for some really, really seamless hot reload in your Flutter app. So if you're working on some Flutter code and you make some changes to your app, and we'll all demo this in a little bit, but you'll see that, you know, as you hit save, that code will automatically be sent to the device your app is running on and automatically, you know, restart with that new code. And because of that JIT compiler, it doesn't have to go through a long compilation step. It can just send the code as is basically to the device, and in development, just kind of compile it as needed, which, you know, has some performance trade-offs, but, you know, in development, those aren't nearly as big of a deal. So you can have the speed of a fully compiled language in production, but then the speed of development of, you know, a just-in-time compiled language, which is awesome. And then also Dart is a heavily inspired object-oriented language, right? It's object-oriented at its core, which in many cases really gives it a leg up when doing user interface development. You know, any of the native user interface platforms out there, whether it's, you know, Windows desktop apps or Mac OS desktop apps, they're very heavily object-oriented, and that's for a reason. It's pretty easy to, it's a group, you know, having inheritance hierarchies represent a user interface definitely comes in handy in many cases. Although you'll see once we actually get into some code that Dart doesn't totally rely on the object-oriented aspects of itself to build user interfaces, but it's definitely just a plus for it, in my opinion. Okay. Any questions before we jump into some basic Dart code? Okay. I'm going to go ahead and, so the first thing I want to do is I'm going to go to this website called Dartpad. I think it's dartpad.dev. Basically, this is an online interpreter for Dart. Something else I'll mention about the Dart compiler is, and this is actually a little bit of a history lesson in Dart itself. Dart was initially created to be more of kind of like what TypeScript is to JavaScript. It was trying to fix some of the typing problems of JavaScript itself. And so what that means is that the compiler has a mode where it can be compiled into JavaScript. And that's what allows a lot of these web-based tools to work out of the box. So anyways, I've gone to Dartpad. I've created this, what they call a new pad, which is just a brand new Dart project. And we're looking at some really basic code right here. So up at the top, we have void main. You know, we're defining a function called main. And one thing to keep in mind, in every single Dart program, the first function to be invoked is a function called main. So that's where your program starts. And it's just by convention that it's called main. If this was called something else, the Dart compiler wouldn't recognize it as the entry point. We have a really basic for loop. You know, it looks like any for loop from any other language. We can see right here that there's a type for this variable I right here. And this kind of brings up the first big thing about Dart that's different from, you know, something like JavaScript, is that it is a strictly typed language. So you'll see a lot of types all over your code that declare what the types of variables are and whatnot. Kind of going down the example, or the starting code, we also see an example of string interpolation. Pretty simple. You know, you can interpolate into a string using $ and curly braces. One awesome little feature I'm going to point out really quick, by declaring another variable here that's equal to that expression of I+1, is we can actually shortcut the string interpolation if we have just a literal variable that we're trying to interpolate into the string. We can actually drop the curly braces. So you also see this a lot in Dart code, where we do string interpolation just with a $ and then the variable itself. But just keep in mind that, you know, if you need to do any more complex expressions other than a simple reference to a variable, you'll need to use the curly braces. When it comes to defining variables, there's a handful of ways to do it. So one is to provide the type of the variable first, and then the name, and then the assignment and the value. There's also a couple other keywords I want to point out. One being the var keyword, which, if you're familiar with C#'s ability to do type inference at compile time, that's exactly what's happening here. So even though we've defined this variable age using the var keyword, if I go down a couple lines and try and assign age to a string, we should see some highlights happening in the, hold on, 1 second. My headphones disconnected on me. Can you guys all still hear me? Can you get a thumbs up?
Yes.
Yep, I can hear you just fine. Yep.
Yep. Cool. It's just my speakers being weird. Okay, so we can see that there's kind of a little highlight going on here and a thing down here in the bottom where we have an error because we're trying to assign a string, to a variable that's explicitly an integer. Even though we didn't explicitly say that it was an integer, the Dart compiler is able to infer that based on the type on the right-hand side of the expression. There's a couple other ways I want to point out to declare variables that you'll see. You might see the const keyword, which just defines a compile time constant. So that means that this variable cannot be redeclared, or not redeclared, sorry, but that means that the value on the right-hand side cannot be computed in any way. It has to be a compile time constant. So if I can't make the age here equal to the result of a function call or anything like that. And then I also want to point out the final keyword. And final basically works the way that const does in JavaScript. So final provides a way for, specifically a way to enforce the ability to reassign variables. So if I try and set this age here again, this is actually an error because we've marked this variable as final. So it's essentially a way to express immutability in some way. Although, as far as I know, it works a lot like JavaScript's const in that, if I assign this to an array or some kind of like dictionary type structure, I can modify the internals of that structure, but I can't ever reassign. I could be wrong about that. Don't quote me on it. Okay, next, let's look at a couple function things. So I'm going to define a function down here at the bottom. And one thing you notice is I don't actually, up here I used this, there was this void keyword in front of the function name, which simply means that this function doesn't return anything. But I'm also omitting it right here. And that's just because if I don't explicitly add a return statement, I can totally omit the return type. But if I am returning something, it would definitely be best practice to add that return type here. And in fact, I think the compiler might enforce that to some degree, depending on the configuration. But let's go ahead and call this function here. I could not swear on the stream. Okay, so to define an argument, I simply use the type of the argument first, provided by the name, and then up here I can pass in a value. Pretty simple compared to looks like JavaScript stuff. But I also wanted to point out a couple awesome features for defining function parameters. So number one is that this is a required parameter at this point. So if I actually omit this up here, we should see the editor getting mad at me for leaving out this argument. But I can make this an optional argument by surrounding it with square brackets. So I can list out a whole bunch of optional arguments to this function by enclosing them in square brackets. 1 second. Okay. Can you all still hear me? Just messing with my headphones again.
Yes, good.
Okay, cool. Also, when I'm defining an optional parameter like this, I am allowed to assign it a default value. So if nothing is provided here, then this value will be equal to the right-hand side of the equal sign. Another awesome feature about function parameters is named parameters. So if I want to accept any named parameters, I can provide those in curly braces here. So if I say string name, when I am calling the function, I can simply list out the name of this variable first, and then follow that by the value. And this also allows me to, accept the arguments in any order, right? So I can also accept an age or something like that. And I can mix this up here. I can pass them in any order because at this point they're named. Or sorry, yeah, because they're named. Although, and I can also allow default values in here as well when I'm using the named parameters. Okay. Next, I wanted to point out just a couple of the simple or basic types of the language, at least kind of the two most popular, those being lists and maps, which are analogous to arrays in JavaScript, and objects or dictionaries in other languages. So if I wanted to create a new list, it's pretty straightforward. It looks like the square brackets, and then I can list out my values here. And then another, and if, I'm using the var keyword here to use type inference, but if I was to explicitly define the type of this variable, I would use the list type followed by a generic type argument for a string here. So this is what the type definition for this right here looks like. The other thing I'll point out is that another way to define this type would just be to add the type just before the opening square braces. And the big reason you would do this is if you were using the var keyword and you didn't have any default values here. If I left this array looking like this, the Dart compiler wouldn't really know what type of list this is, and it would actually kind of go into what they call a list of dynamic. And I'll talk a little bit more about the dynamic type in a minute. But if I want to explicitly mark the type of some list, I can prefix it just before the opening square bracket with the type of its contents. And then also, I was talking about maps for a second. Once again, maps just being like a dictionary of sorts. And basically, I provide a list of key value pairs. So I can provide a key and then some value. And the type definition for that would simply look like map string of spring. And another option, if I don't provide any values here and I want to still explicitly set the type, just before the opening curly braces, I can specify those types there. Okay. So that is lists and maps. Going to keep moving pretty quickly here. I got kind of a long list of stuff to show off. Stop me if I'm going too fast or if anyone has any questions about any specific syntax, because I'm happy to take a few minutes and explain it better or go into some more examples. Another thing that I'll mention about Dart is, a lot like JavaScript. You'll hear me say that a whole bunch, a lot like JavaScript, because this is a very similar language to JavaScript. There's just a couple of slight differences. But a lot like JavaScript, functions are objects and first-class citizens in JavaScript, and so they can be passed around between objects and functions. And what that means is that Dart also has built-in support for something like a lambda, right? So if I wanted to use the for each loop that exists on each list, let's actually go ahead and fill in some values here. So I'm going to say this is a type int and just add a couple values in here. So I could go down and define, like a function that takes in an int of, one int, and I could pass that in here, but I can also just define it inline, which looks like this. And then I accept the item property. So just like in the JavaScript for each, you pass it a callback function, which is what we're doing here, that accepts a single item. And once again, the Dart compiler is being really smart here. It knows that we are looping over a list of ints. And so if I look down here at this documentation, hovering over int, it's automatically telling me that this is an int argument because we're looping over a list of ints. And then I can, do whatever I want inside this function body. Another version of the Lambda, very similar to JavaScript, is the fat arrow syntax. So let me declare a new list here, and we'll use the list map method to transform each value in this array. So if I go my list.map, I can take in my item and use this fat arrow syntax to then to write another callback in here and transform that value in some way. So if we break down what this code right here is doing is, number one, when you use this arrow syntax, whatever expression is just after the arrow is implicitly returned. So you can imagine that there's almost like a little return statement right here that returns this value. And then map, if you're familiar with the way the JavaScript map method works, it runs each item in this list through this function, takes the return values of each of these functions and puts them in this new list. So we should see hello, followed by the number here. The other thing that I'll mention, one difference when it comes to JavaScript, is that in JavaScript, normally you can omit these parentheses if there's only a single argument in the callback, but that is not how it works in Dart. They explicitly want the parentheses around every single time, no matter how many arguments you have. Okay. I also mentioned that I was going to talk a little bit about the dynamic type, and basically the dynamic type in Dart works a lot like the any type in JavaScript, and it also, or in TypeScript, and it also is just kind of like the default behavior for variables in JavaScript. So if I go up here and say var name and don't actually provide it any default value, what the compiler is going to do is assign it to a type of dynamic. And at that point, I can actually do a reassignment. So I could assign this to a string, but then a few lines later, I could assign it to an integer. So at this point, it behaves almost exactly like JavaScript. But when it comes to strongly typed languages, it's best to avoid that where possible, so that your editor can actually give you hints about what kind of data this is. And at the same time, the Dart compiler, since it's compiling into native machine code, in many instances when you provide explicit typing, you're normally able to compile down to more efficient code than if it had to use the dynamic keyword everywhere. Okay. And just the last thing I'm going to touch on really quick, we're not going to run into any examples of this when we're writing any Flutter code, but it's a little known detail that tripped me up at one point. If you're familiar with languages like C or I'm pretty sure in C# as well, if you take two integers and divide them, you would expect that these, since you're dividing integers themselves, they will return another integer, which means that in this case, we should get back 1 since it's throwing away the remainder. But if I run this, you'll see that it actually returns a double. And that's just kind of how it works by default. But if I wanted to fix this, I use a special operator in Dart called the integer division operator, which I just prefix my divide operator with a tilde, and then at that point it'll run integer division. Little detail, not something you'll run into every day, but something that tripped me up and drove me nuts for a solid few days. Okay. Now I want to talk about classes and objects in Dart. So to define a class, just use the class keyword and define, just add some curly braces, and boom, we now have a class that we can create instances of. If you want to create a constructor for the class, you just simply use the name of the class as the name of a member function, and we have a constructor. To define properties, you list those out just as what looks like top level variables. If I want to pretty bitwise negation. I'm not sure. You can look at the Dart documentation, Fred, to figure out how to do bitwise negation. Don't have that one memorized. But anyways, back to the constructor. I can accept a constructor argument here and define a body and go ahead and assign that argument to my default property. If you've done a lot of object-oriented programming, you're probably really familiar with this setup here, where you define a property, accept it in the constructor, and then in the constructor body, assign it into the property. Since this is something that you do so often, especially in Dart code, there is a shortcut to all this where you can completely omit the body, and you can also omit the type argument and simply just say, prefix the argument with this. And so what that's going to automatically do is whenever I create a new instance of this class, you'll see that it automatically assigned it to my property. So as long as these two are the same, Dart's going to automatically assign this argument to this property. And we could also swap that for a named parameter, and it works the exact same. So we'll see this dot name. If I come up here, we'll see we can specify the name at this point. We can also do inheritance in Dart like you would expect. So if I have a class employee that extends person, it now has all the properties of person, and I can define my own constructor here for person. Let's add a new property, like the employee ID or something like that. So I could define a new constructor that takes in this .id. And I would also want this to accept name. So I'll actually write this just a little bit differently. And then at this point, what I want to do is essentially just call my super classes constructor. And for explicitly calling constructors and superclasses, instead of defining like a function body and calling super, you use a colon after the beginning of the constructor name, and then run super, passing the arguments through. So this right here is we're defining a new constructor here that's taking in the ID, automatically assigning it to this property, and it's taking in the name, and then passing that to the superclasses constructor. And what? Oh, I spelled things wrong. My bad. So then at this point, I could come up here and swap this for employee. And now I can also pass in some kind of ID at that point. Another thing that I wanted to call out really quick was interfaces in Dart. Dart doesn't have the interface keyword. Instead, you can essentially just adopt the interface of any existing class. So instead of extending from person, let me remove this super call here and replace a couple things in here to make this look like a person class. If I come and change this word right here from extends to implements, at this point, if I didn't have like this property in here, we were not adopting the public API of this person class, and so this will throw an error. But once I add that property back in, at this point now we are adopting the interface of the person class. So this is how you handle interfaces in Dart. If you don't want to define an actual class and want something to look more like an interface, it's recommended to just mark that class as abstract so that you cannot create instances of it. And that's kind of the default way to do interfaces, but there isn't like an explicit interface keyword in Dart. Another thing I wanted to touch on was additional constructors. So right here, where I'm using the name of the class as the name of this method, I'm defining what's known as a default constructor. But I can have constructors with other names, and they call these named constructors. So to define one of those, I use the name of the class followed by what I want the name of the constructor to be. So I might have like a from JSON method that takes in a string of JSON data, and then from that is able to, assign to my ID and name properties. And then when calling it, I simply just call employee.fromJSON and pass in my string. Another option for constructors is to prefix the constructor with the keyword factory. And then at this point, this function right here is allowed to use a return statement. And so from here, I can return like maybe a cached instance of this object, or even then I could maybe call into another constructor to create the instance. But whenever you want a constructor to explicitly return some value, which the return type is going to essentially be, employee in this instance, then I mark that as a factory constructor. Also not something you run into super often, but it was something that was really confusing for me, at least at the beginning. Dart also has built-in enums, so I can use the enum keyword to define like an enumeration of values, so some static list of values. So in roles here, we might have sales and marketing, and then we can assign those to potentially properties on employees and use those in if statements and all sorts of stuff. Okay, so let me go back to just my person example that I had. Get rid of this enum, and I want to load up a little bit of an example on something you run into in almost any programming language, and talk about some really unique ways that Dart has solved this problem. So I'm going to create another class. We're going to call this a vehicle class, and we're going to say that people have vehicles by default. So I'll come down here, and we'll have a vehicle type of vehicle, and I'll accept that in the constructor automatically, and we'll say that vehicles have a certain number of wheels. Just so kind of a little bit of a silly example here. Fred asked if Dart has multiple inheritance. It does not have multiple inheritance. It has single inheritance, although one way that you kind of can get around that is using mix-ins. So Dart has a with keyword where you can, I could extend some class here, but then I could also say with and include some mix-in. I can't remember exactly what the limitations are with mix-ins. There's a handful of them, but that's kind of the only way you can achieve something like multiple inheritance. Back to the example. Let me finish my constructor for the vehicle class. Okay, and I just deleted this line of code and I have to add it back. Levi equals person. Oh, something I totally forgot to call out that I was doing at the beginning is I can create instances of classes without the new keyword. The new keyword is optional in Dart. You'll see why this is so awesome once we actually get into some Flutter code, because you're creating instances of classes pretty often. So the new keyword is entirely optional. Okay, back to the example. Let me kind of finish adding in a couple parameters here. So we'll pass in a vehicle with, we'll say this is like a bike or something. So it has 2 wheels. And now if I wanted to print the number of wheels that my vehicle has, I would say Levi.vehicle.wheels, right? And this should compile and run. So let's run that, make sure it prints out the number 2. Awesome, but what happens if we don't actually provide a vehicle to our class at all? If you'll remember, these named parameters are entirely optional, so it's not a compile level error to not pass in an instance here. But if I go ahead and try running this now, you'll see we get an error, right? And it's essentially a null reference exception because we're trying to access this wheels property on this vehicle property, which is null. By default, anytime we don't provide a value to some kind of variable or property, it's automatically assigned to null. And so there's 3 operators. They're called the null aware operators in Dart that make dealing with this this type of setup really, really nice. So the first one that I'm going to talk about is the conditional member access property. So basically, whenever I'm trying to use the dot operator to go in, grab some property, and I think that the value could be null, I can essentially prefix the dot with a question mark. And now if I try and run this code, you'll see that instead of getting an error, we actually just get null. And what happens is, Dart tries to access this value, which is an instance of an object, and then it tries to access this property, which is at this point null. And so then it sees the question mark operator and knows that we're trying to be smart about this, and essentially just short circuits the entire expression to just simply return null. So this entire expression just returns null. But if we actually had provided a vehicle, you can see here, we should actually get the number 2 instead, because we were able to safely access that value since vehicle was not null. Another operator that comes into place, we had printed out null here. Maybe that's not what we were actually looking for. Instead, we wanted to actually print out some real value. We can use the if null operator, which is a double question mark. And basically how this one works is it looks at this expression on the left, and if it ever returns null, then it automatically returns the value of the entire expression will be the value on the right. So at this point, we'll still see 2 here because this never showed up as null. But if I go and remove all of this, or even if I just removed the wheels argument here so that the property in our vehicle class was null, we should see it print 4 this time, because this whole thing is short-circuited, therefore resulting in this being null, therefore returning the right-hand side of this expression. And then the last example of a null-aware operator is what's called the null assignment operator. So the vehicle property on my person class, it's a public property, so I can actually reassign it. So I can assign it my own instance of a vehicle. But one thing that might be nice is, if there was already an existing vehicle here, this equal sign would overwrite it. And so that's where the null assignment operator comes in. So if we do a double question mark equals and finish creating our class here, in this instance, it's going to first check that the variable the value we're trying to assign to is not null. So if vehicle is null, it'll do this assignment. If the vehicle is not null, it's going to essentially skip over this line. So in this case, we should see this print out 3. And there we go. But if I had passed in my vehicle, like I had before, with wheels 2, at this point, we should see it'll print out 2. And this assignment didn't happen. Okay, we're almost done with the start section, and then we're going to jump into some Flutter code. So the last bit that I want to talk about is in terms of syntax and language features before we start diving in is the kind of built-in async nature of Dart. So, oh, whoops, I was not supposed to delete any of that. We can keep all that in there. So let's go down to person here, and I'm gonna define a method here called takeNap. Something simple. The main point is to theoretically, this method should take some amount of time to actually run instead of just instantly returning a result. And if you're familiar with JavaScript at all, you've probably heard of the concept of promises. And essentially, promises are objects that represent some kind of asynchronous operation that in the future is going to finish and give some kind of result. And then people who care, parts of your code that care about that result can then listen for that change to come through. And Dart has the exact same concept. It's just under a different name. It's called a future. So instead of returning nothing from this method, I'm actually going to return a future here. And the compiler will throw an error here since we're not actually returning a future. So I'm going to return an instance of a future that I'll create using the delayed constructor. It's just a simple way to wait a few seconds for something. Delayed expects an instance of this duration class, which is a built-in class to Dart. And we'll just say second1. So now what should happen here is if I run takeNap somewhere, so Levi.takeNap, the first thing I'm going to do actually is print out that our program started so we can see when the compile is finished and the program's actually running. But take nap is going to take a second or so to actually run. It's going to take one whole second before it's finished. And so to wait for it to finish, we actually use the same API that we do in JavaScript, which is .then. So if I add a .then statement and pass in a parameter, in here I can print out nap, woke up from nap or something. Woke up. One thing the compilers get mad about is futures normally return some kind of value, and so it's expecting something in here, even though by default the delayed constructor for a future doesn't really return anything. If we don't really care about a function argument, it's standard to just use an underscore as a placeholder. So in this case, if we run this code, we'll see this print statement get run, and then a second later, this woke up statement get run. Another way to make in this case, we can mark the return type as future because we're actually returning a future. But another thing we can do is actually mark the function as async. And whenever you mark any function as async, the return type of that function is automatically future. And then the other advantage that you get when your return type is async is that you can use this await keyword to pause execution of this function, if you will. So what's going to happen is let's print out something right here. What's going to happen is we're going to run this method. This is going to we're going to enter this function body. Dart is going to see this await keyword after this future, and it's basically going to pause the execution of this function. Now, it doesn't pause the execution of your entire program. It just pauses this particular function. Other things might be happening in the background in other places. In fact, if I had a line of code right after this, it's going to print this thing first before any of this happened. Program execution continues because this happens asynchronously. But then I can add multiple await statements to this function. So if I come in here and add maybe a few more, let's copy this guy. Or put a couple more of these in here. You can see that basically our code is going to come across each of these and just wait 1 second and then run the next line of code and then wait 1 second, or it's waiting 1 second, but really it's waiting for something to finish. So if I go ahead and run this, you'll see program started, and then we'll see, after a second each time, we'll see each of those print statements run. If you've ever done any of work with promises in JavaScript, any async await stuff, you'll probably feel right at home with this concept. It was definitely modeled after the JavaScript promise-based stuff. So, but I also want to just point it out that it's there and definitely used heavily. Okay, so any other questions kind of just about Dart as a language or any of the syntax that we covered before we start diving into some Flutter stuff? Okay, not seeing anyone. Hopefully everyone's just saving all the good questions for the end. Do I know how they implement the async stuff? Not really. It's kind of built in as a language. I know that that Dart has somewhat of an event loop. libuv like or other. Yeah, I'm not really sure. All I know at a high level is just that Dart has some kind of event loop, where it's maintaining call stacks and whatnot. And it's modeled a lot of how JavaScript works. But yeah, I'm not totally sure exactly how they implemented it underneath the hood. Okay.
I have a quick question.
Go ahead.
When you were learning this, did you start with Flutter and then backfill your knowledge of Dart, or did you start with Dart and then go?
So I kind of looked at maybe the very intro to Flutter, but then I took a step back and read through some of the Dart documentation just to get up to speed, because whenever I'm learning some kind of new technology, the last thing I want is to get hung up on the language details, because those always just make me stop for a second and have to think about things. Quite a few things that tripped me up was syntax like this, right? Like the optional arguments with also automatically assigning to properties. And so for those reasons, I specifically wanted to get started with the intro to the language itself, because it's something that, it's not a popular language, once again, so not very many people are probably familiar with it. But yeah, I kind of took the same approach, after just looking at a couple very basic things. Cool. Okay, well, I guess we can get started on some Flutter stuff then. Now we got all the boring stuff out of the way and we're most of the way through the presentation. Let's look at Flutter. So I'm not going to walk through the Flutter install process. I'll briefly touch on it. If you go to the flutter.dev website, go to the Get Started button, you simply just choose your operating system, you download the SDK and follow those instructions. Essentially, it's going to have you extract this zip file, put it somewhere on your computer, and then add that folder to your path so that then you have access to this Flutter command. So if I go to my terminal, I've already installed Flutter, so I should be able to run flutter-v or something like that. I don't remember which one it is. Flutter -- version, I imagine. Yeah. And that's going to give me the version of it that I have installed. It might even be a newer version than this, but all this stuff will apply for even a newer version. They haven't made any crazy changes recently. So then to create a brand new Flutter project, you simply run flutter create and then the name of the project. I'm going to call it SGF devs. It's pretty standard in Dart projects to use underscore case or what do they call that? Snake case, I think, for defining project names. So and packages too. So packages and project names, whenever there's a space, there should be an underscore instead of like a dash or an uppercase character. And then I'm going to open this project up in my favorite IDE. Let me pull this up. I'll also mention that Flutter doesn't have like a go-to IDE. They support kind of all the big players out there. So they have plugins for Visual Studio Code. They have plugins for IntelliJ, which is what I'm using, as well as Android Studio and the like. So just kind of look for, I'm sure there's a page on their website. I can't remember exactly where it is on editor plugins, but you should be able to find one to fit your editor there. The other thing I'll mention that when I ran this command to create the new project, it's building out a whole bunch of files and folders for me. And then also at the end, it runs this Flutter Doctor command. And I'll just run that again really quick to show that off. But Flutter Doctor is basically a little debugging tool just to make sure that you have Flutter set up correctly. So after you've installed Flutter, you can run this Flutter Doctor command to make sure that you have everything in the right place. If I go up here and look, it's saying that I have the Flutter SDK, I have the Android toolchain, which means I have the Android SDK installed, which you can get from Android Studio. I have Xcode. It's giving me some warnings about IntelliJ, saying that I don't have the proper plugins installed, even though I definitely do. It seems to be a bug with Flutter Doctor not recognizing some things. It's recognizing the VS Code extension that I have, as well as it's recognizing a device that I have running. I have right here an Android emulator running that we'll deploy our app to in a few minutes. Okay, so now we're looking at the very basics of our Flutter app. So we have this main.dart file. And if I go over to let me actually enter in the presentation notes. This is a little bit bigger. I know you guys can probably all see, but it definitely shows up better in the recording to have a bigger font. So I'll pull up my sidebar and let's kind of walk through first and foremost this directory structure and what's in here. These folders that start with a dot, not super important. This one's like a kind of build folder for Dart. This one's an editor folder. We then have this Android folder, and this is actually a full-blown Android Studio project. This has all the files and configuration that you would expect to see in a normal Android app. And if I actually, this is going to jank up my editor since it's not configured to do Android apps, but if I actually go through and open this Kotlin folder and look at this main activity class, we'll see this actually looks like any old activity class from any Android project, except it's inheriting from this Flutter activity in this Kotlin code here. And that's basically what a Flutter app looks like. It's an Android app that then Flutter takes over. And then the same thing over here on the iOS side of things. So there's an iOS folder. This contains a full Xcode project. Inside of this runner folder, we have our app delegate for our Swift app. And here it's inheriting. So here's the Swift code where we inherit from a Flutter app delegate, and the app boots up and gets running. The good news here is that you actually commit these projects to your Git repository. And you can actually make changes to them. So if you need to make some native configuration changes to your project, you can go in and do that. You can also go down and write some native code to add to your app. And Flutter also comes with a communication layer to communicate between your Dart code and your native code in many instances. Then we have this lib folder, and this is where all of your Dart code actually lives. So as you add files and folders to your project, you will all basically add them all into this lib folder. Underneath that, we have a test folder. This is where you write tests for your apps. I'm not going to dive too much into testing for this because mainly we're just getting into the basics, but all your tests would end up living in there. There's also a way to do automated UI tests, and those would show up in a separate folder. And those are obviously awesome to watch. You can just have that tool launch the app on your device and sit there and click things around for you and whatnot. It's pretty cool. Below that, we have kind of some other standard project files like a README and a getIgnore. This metadata and packages folder or files, these are all handled by Flutter. You need to commit them to your repo, but you don't actually need to edit them, as well as this pubspec.lock file. The only other really important file here is this pubspec.yaml. And pubspec.yaml is essentially the package.json of Dart projects. So this contains metadata about your project, as we can see right here, like the name, description, and version, as well as dependencies. So right here, we list out our dependencies. And Dart uses a, what do they call it? A repository called pub. So if I actually go back to my browser here, I think it's just pub.dev. Yeah. So this is the online repository for all sorts of Dart packages, and how you manage them in your project is in this pubspec.yaml file. And then also we can add just other random bits of configuration. So Flutter specifically has some configuration things in here to pull in, things like fonts, and images, and whatnot. Also in my editor here, I'm using IntelliJ, but I have the Dart and Flutter plugins installed, so it's actually automatically adding some UI up here for me. So right here, I have a button I can click to automatically download any new packages I've added, as well as a couple of other tools. Now, really quickly, let's actually start up this app on a device really quick. So I'm going to exit presentation mode to make sure that I have my emulator selected, and we'll go ahead and click this play button here, and it should start up and connect to this. This will probably take a second because it's a brand new project, so the compile is going to take a little bit longer. Okay, we see it going on here. While that's happening, I'm going to jump back over here. I'm going to remove. This is kind of the default app that we're looking at here that Flutter has generated for us. And I'm going to take a second and just remove all of the comments from here, just because I'm going to be going over them manually, and in the full screen mode, it'll be a little bit easier to see. So I'm going to do this really quick while that build is happening. Oops, cancel. The very first build definitely takes a few minutes. Subsequent builds shouldn't be as long by any means. Okay, so I've removed all those comments, and then we come back in. That should look a little bit nicer. I'll jump back into the full screen mode, and we'll come back over to this guy and just wait a few more minutes. One second now. Anything go wrong, or is it just taking a minute? It really is just being very slow. Ah, there we go. We're getting something. The biggest reason that takes so long the very first time is it's got to do a full Gradle build on the Android side of things for the very first time, which definitely takes an extra minute or two. And just a second, see our UI pop up. Come on. Everything takes twice as long in a presentation, I promise.
It's Zoom eating up all your memory.
That's actually probably what's happening. Things were getting real laggy for a second there. So I think the video call is definitely lagging things up a little bit. Okay, cool. So the example app is it's nothing to write home about by any means. It's a pretty simple app that just has it's tracking just the teeniest bit of state, just a very simple counter here. But one of the main features I wanted to show off really quick, if I can move my editor over to one side, if I come in here and find some of this text, like this Flutter demo homepage, and I come over here and we'll change this to say SGF devs, and I save, we should see in just a second the app automatically reloads with that new configuration. And that's just goes, it was basically instantaneous, and that goes for almost all of the code in your project, right? Like there's only a couple instances while you're writing code that you actually need to reboot the app, and maybe most of those are just when you're kind of depending on maybe like some lifecycle methods to set some stuff up or something like that. So the hot reload in Flutter, absolutely amazing. So
it looked like it did an intelligent reload too, because it didn't change the counter.
Exactly, right. It keeps as much of your state intact as possible. It kind of surgically updates what it needs to. There's a couple instances where it doesn't totally hang on to everything, but yeah, good note on the intelligent reload. Okay, right at the top of the file, the first thing I want to point out is this new bit of syntax that I didn't talk about, and that's this import keyword. This is how you pull in references to other files and packages into your app. So right here, we're importing basically the Flutter SDK at this point, Flutter material, and that provides us with a whole bunch of functionality. In fact, if I comment this out, you'll see all of these things that were read were pulled directly from that library. If you are familiar with the import syntax in JavaScript, this might trip you up a little bit because you don't see like an import run app from package Flutter material. Instead, all of these functions and classes are directly imported and don't need to be, like they're kind of implicitly imported from that statement. There are a couple of various options for importing. So like if I don't like this and I want to specifically import, like this run app function, for instance, comes from the material Dart, I can use the show keyword here, followed by the symbols that I want to import directly from there. So in this case, I'm importing just run app. And then another option is, this is especially helpful if, multiple packages use the exact same name for some function or class. You can use the as keyword to put all the imports under a namespace. So in this case, I'm saying as material. Then in front of all these things that are red, I would have to prefix them with material dot at that point. It is best practice 99% of the time just to go ahead and leave it as is. Most of the Flutter code that you'll run into looks just like this, right? Where it's literally just importing the SDK right up front. The other thing that I'll mention is with this syntax, you import packages with the package prefix, but you can also import files from your own project. So if I say import package and I say SGF devs, my project name is technically a package at that point, and so I can import some file in my lib folder directly this way. Okay, now let's start diving into Flutter. So right at the top, we have our void main function, the entry point into our Dart application. And then we have this run app function that comes from material. And I'm going to go ahead and command click on this to go view the source code, or at least the definition for it. And in here we say void run app, and it takes an argument of type widget. Okay. And if I jump back, you can see we're creating an instance of this my app class that extends stateless widget. And so it should stand to reason if we jump up the inheritance chain here. So I'm clicking on stateless widget. We see that stateless widget does in fact extend widget. So we're passing in the right type there. But what exactly is a widget? This is probably maybe if you've never done any Flutter stuff, you're probably like, what the heck is a widget? But the easiest way to explain it is probably to compare it to some other frameworks like React specifically. So, React or Vue, those frameworks have what are known as components, right? That represent some kind of piece of UI, right? And the same concept is there in Flutter, but they call them widgets instead of components. So an easy substitution, at least right at the beginning, is to just consider the word widget to mean component, right? So whenever we want to create our own widgets, which we don't have to, there's a whole bunch of widgets that are built into material. There's widgets for buttons and pieces of text and whatnot, but they don't do anything on their own. We need to bring them together in some way. And how we bring them together is by creating our own widgets and composing all sorts of other widgets together. So I mentioned at one point that Dart is definitely an object-oriented language, but that doesn't mean it like depends heavily on things like inheritance, although we see a little bit of that here. But Dart and Flutter specifically, they really rely on composability instead of inheritance chains. So instead of inheriting from and overriding members of other classes, we only do that in a couple places. You might see this override for this method here, but instead we're building our UI based on instances of other classes, or in this case, instances of other built-in widgets. So right here, whenever we have a stateless widget, the only thing we need to really do is override this method called build. And build needs to return another widget. And so at this point, we can see we have a return statement for a material app. And I guarantee if we go up the inheritance chain for material app, it'll definitely be a widget. My IDE is not complaining at me. So material app is some kind of widget. I'm not going to dive too deep into what it is, but it takes a whole bunch of named arguments here, right? This theme that takes an instance of theme data. Theme data is not technically a widget, although it kind of looks like one in this context. But then also it takes in for home, if we go look at this property specifically, it just wants some generic widget there. We can pass in anything we want at this point. We could just put in a piece of text if we wanted to. There's a widget called text that we could pass in here, but instead we're passing in my homepage, which is a custom widget that we've defined. Now, before I dive too deep into my homepage, I want to take a second and kind of explain the purpose behind the build method. If you're familiar with React, Flutter was heavily inspired by React. So you'll see a lot of similarities here if you've ever done any React.js. But essentially, build is a method that's going to get called a whole bunch of times over the life cycle of our application. In fact, one thing to call out really quick is that widgets themselves are considered to be immutable. They should not change at all. If I wanted to define some property on my widget here, and even assigning it a default value, my editor is kind of blowing up at me over something right here. If I hover over this, let's kind of see what this is. It inherits from or is marked by, it inherits from a class or is marked as immutable. So these classes themselves, or any instance of a widget is supposed to be immutable. So one way that I can get around this is to just simply mark this as final. And what that means is that widgets themselves don't contain any bit of state. They, once again, are just kind of like a blueprint for what the UI should be, and they don't track any long-lived values. And they build up that blueprint through this build method. So the Flutter framework, based on configuration changes, state changes or whatever in my app, it might call this build method over and over and over again. And something else to keep in mind with that is that means that you want to refrain from doing anything besides putting widgets together inside of build methods. The last thing you want to do is start this method off by kicking off some kind of HTTP request, because that HTTP request is going to get called every time your app basically re-renders, which is going to be pretty often. And if you're familiar with React at all, a React component has a method called render that does basically the exact same thing as this build method, right? It's responsible for explicitly just returning, in React's instance, some markup, right? In Flutter here, it's a collection of widgets. So now let's jump down to this homepage. And homepage looks a little bit different. Instead of extending stateless widget, it's extending stateful widget, which kind of based on the name, you would assume that a stateful widget can actually have some state compared to a stateless widget. But that's not totally true. The stateful widget on its own doesn't actually maintain any state. In fact, if I try and do that same thing where I declare a property and make it not or mutable, right? We should see my IDE blow up about the same error here, right? So, yep, it's marked as immutable. So we're not allowed to track our state in here. And once again, it's just because Flutter wants to be able to rebuild our widgets very easily. It's gonna throw instances of our widgets away all the time, because every time this build method gets called, it's creating an instance of material app, it's creating an instance of my homepage, and which would mean that if it was creating a new instance of my homepage and we were tracking some kind of mutable state here, that would be lost. But stateful widgets have an additional method, or well, the important part of a stateful widget is it has this create state method, and this create state method is supposed to return an instance of what's called a state object. And we can see that down here in this my homepage state class. And the pattern here is that every time you have a stateful widget, it will always be accompanied by a state object that represents the actual state of that widget, right? The long-lived values. And what happens here is, Flutter is going to sit there and create instances of my homepage state as often as it needs to. But because we have this create state method kind of in a separate method, Flutter is going to hang on to this instance between the instances of this class that we create, if that makes sense at all. So it'll create new instances of my homepage, but it's going to keep reusing the same instance of my homepage state. And so if we come down here and look at my homepage state, we can actually see that here is where we have some mutable state, right? We have a counter property here that is not marked as final, and it is perfectly valid to use it that way. There's also a whole bunch of other stuff that goes on into state objects, but we're going to actually jump down to a familiar looking method, which is called build. And this contains the kind of UI configuration for our whole stateful widget. And one thing that kind of when I was first looking into Dart or into Flutter, this whole concept was very confusing. Why is the build method in this other state objects? It makes sense that it would be with the widget, but that's just because the build method itself is in many cases where you want to use some of this mutable state, and so that's why the build method is down here in the state object instead of back up in the stateful widget. So realistically, the stateful widget is just kind of how your this whole setup gets used inside of other widgets. While the state object is kind of where all the main logic lives. This is just kind of the entry point into the widget, if you will. This is where we accept arguments to the widget, right? We can see that right here, where we're accepting a title into our stateful widget. And we can access any of the properties from our parent widget down here in our state object. And we can see that right here. We're using this widget property. State objects have a built-in widget property that is equal to the current instance of our stateful widget. And we can then use any of the properties from there that we've passed in down here. But then we once again jump down to our build method. We're returning a scaffold, which, once again, if I go up the inheritance chain, it's definitely a widget. And a scaffold, jumping back up, this material app, I kind of skipped over what it does, but a material app essentially sets up the very basics for what it says, a material app. It's going to set up kind of some styling configuration. It's got a whole bunch of default values for like this theme here that a whole bunch of other material-based widgets depend on. So this is kind of doing like some just absolute basic setup stuff. But then if I go back down to scaffold, this is actually kind of setting up the basics for a material app layout. So if we actually look at some of the top level properties here, or the arguments that we're passing in, we're passing in an app bar, which is, if I go over to the emulator here, that's this little bar up here at the top. So we pass in an app bar, we pass in a body, which is this main bit of content. We pass in a floating action button, which is automatically going to be placed here. And we didn't really have to specify to Flutter where all these things went. That's kind of what the scaffold widget is there in the first place for. It provides a default place to put all of those things. If we open up AppBar accepts a title where we then pass it a text widget. And I think title could actually be any old widget, right? So we could actually do some more custom bits of UI in here. If we wanted an image in our AppBar, that would totally be possible using some kind of image widget. But we're instead using a text widget, passing in our little title from up in our stateful widget. And then we have the actual content of our app. If we look in here, there's a couple other widgets. There's this center widget, which essentially tries its best to horizontally and vertically center its child in the screen. So this is the center widget itself is gonna take up as much space as it can whilst trying to center its child. The column widget is a layout-based widget that just arranges its list of children in a vertical column, right? There's also a corresponding row widget for laying widgets out in a row side by side. In here, we pass in a list of children where we can pass in any widgets at this point. The argument here is a list of widgets, right? And we can pass in any widgets we want here. And then we also have this one here where we're actually using our bit of mutable state right here, right? We're using our counter automatically, and then a couple other pieces of configuration. And then the last part is the floating action button. It has a few things. It has an icon that it's adding in there, as well as this onPressed callback, which runs a method we have called increment counter. And if we go up and look at increment counter, it's pretty simple what it does. The main bit of logic is this part right here where we increment the counter. But then the other part is this call to set state. And this set state method is something that all state objects in Flutter have. And basically, the whole concept behind set state is once we are done mutating all the properties in our state object that we need to, once we call set state, Flutter will automatically rerun the build method in our widget. And when it reruns this build method, it's gonna, this counter variable will then be updated. And then when the build method's finished, we'll have used our new state value in our counter. And that'll automatically get reflected in the UI. And we can do whatever we want here. We can times it by 2 and have a bit of counter equals counter times 2. We can do kind of whatever logic we want right here. That doesn't matter. In fact, I could do the logic before the set state call. But just know that the UI isn't going to update until we actually run the set state. And basically, whenever this callback inside of set state is finished, essentially directly after that is when the build method in our widget gets recalled and our UI gets redrawn. So if I save that and go back, we should see that now things start being multiplied by 2 automatically. And we still hung on to that state, which is super awesome about Flutter. This didn't get reset to 0 at all, which is really cool. Anyways, I know I'm running kind of long on here, but that's kind of the basics, absolute basics of Flutter. I know I didn't get too much into there because I definitely wanted to make sure the language fundamentals were down, but I wanted to make sure to take a couple seconds and see if anyone, or take a few minutes and see if anyone has any questions about what some of the basic stuff that we've gone over.
I don't understand how the create state return _ my homepage state doesn't create a new instance each time. Is that something where you need the new keyword if you wanted it to be a new instance, or is it some special cache thing? Because
it's essentially a special cache thing. So you're just defining the method create state here, but you as the programmer never actually call create state. The Flutter framework behind the scenes is what's going to call create state for you. And it's going to take the return of this function and actually store that kind of in memory somewhere as something that it needs to keep long-lived in memory and not destroy over and over again. Does that make sense?
Oh, so it's not being called each time the page is rendered. It's only being called very infrequently. Right.
Yeah. It's basically only called at the beginning, the very first time that this widget gets built. That's the only time create state is called. Whenever that's not the only time, if for whatever reason this object needed to be restored or deleted, which the main instance of that is if for some reason this build method no longer returned this widget at all. If we had some conditional logic or something in here to no longer render this widget, then the Flutter framework at that point would go ahead and delete our state object. But then the next time we rendered, this widget, it'll recognize that there is no state object, and it'll create it automatically.
So Levi, man, Austin. First, thank you. This is pretty damn cool.
I'm glad you like it.
Really valuable. From like I guess like a longevity, if that's the right word. Like,
sure.
Like, what's your sense of Dart? Because I've been through like a few of these like cross compiler things, and
sure.
It's always sad when you invest time like learning something and building stuff, and then all of a sudden the community is like, sorry guys.
Right. Yeah. No, I totally understand that. You're right. Yeah, I've heard of these things before. So, I mean, the biggest thing I have in my mind behind why it has some staying power is just that Google is putting loads and loads of effort into this language. The language itself was created by Google, as well as Dart, right? And Google has very large projects on Dart and Flutter. The entire AdWords stack, the web app and the mobile applications, is all Dart.
Oh wow!
So
okay.
The web app is using Angular Dart, which is a Dart version of the Angular framework, and at least it was built that way a couple years ago. I don't know if they've changed it. And their mobile application is written in Flutter. So there's some staying power there, at least from Google, right? So that's at least one reason I would say that it's going to stay around a little bit longer. And Flutter itself has only been in stable mode for, once again, like maybe just over a year, and it is absolutely insane how much traction it's begun to take off in just that year. So I don't see any signs of it slowing down, which gives me hope that this language isn't going to die off anytime soon either.
Have you been through any of the like upgrades and like churn and upgrade cycles? Like what's been your experience with that?
I haven't yet, honestly. So I can't really speak to that directly. I follow a little bit of what's going on with updates, and I haven't seen like a ton of crazy breaking changes. As I understand, a lot of the updates that the team is currently working on is really trying to push to get the Flutter web and the Flutter desktop versions working, which is essentially going to allow you to single code base all the platforms, all the things, right? Which is going to be insane. I know a lot of things have been promising that for a long time. In many cases probably based on web technologies, but things just seem a little different with Flutter, in my opinion, because they're really trying hard to hit those performance benchmarks and make sure things run smoothly. So
you're saying that Google is potentially, instead of sticking with Go, they're going to move to Dart for their applications?
I wouldn't say that at all, because Dart is a very different language than Go. Go is like kind of more of a back-end language and not really a user interface language at all. And Dart is much more of a user interface language and not really for the server, although there are server-side frameworks for Dart as well. Dart is definitely, its focus at the, when it was initially created was for UI. And so I don't think that they are at odds with each other by any means.
I have more if nobody else is going to go. I just don't want to ask all the questions.
Go for it.
Yeah. So you said there's like really extensive UI testing. What does that look like?
So I haven't done much of the UI testing. All I know is that it's there. So one thing I'll pull out really quick is this book right here that I read through a couple weeks ago, called Flutter in Action by Eric Windmill. It talks a little bit about testing in there, and he just kind of highlighted some of the big parts. So the first things, you can do unit testing all you want, and you can also unit test these widgets themselves, where you don't actually have to run them in a full environment. But then there's also what they call, I think it's called the Flutter driver package, which is where you actually hook up a mobile device or an emulator, and all your UI tests then run like natively on the device, and it sits there and clicks around and does all the stuff that you want it to. And that's also how, in many cases, how apps are profiled too. That same Flutter driver package is used to run profiling tests against apps as well. But also not something I have a ton of experience with.
Okay.
Any more questions? There was one thing I totally forgot to mention. This was a big complaint against Flutter when I very first started. It was something that kind of turned me off at the beginning. One thing you'll notice right here is I'm basically building UI with code instead of using some kind of markup language that you would expect in anywhere else, right? If you come from the web, you're very used to HTML and CSS, right? But in Dart, none of that exists. Instead, you're just dealing with raw code. But the thing that made it finally click and work for me and help me get over it was, if you have a decent editor out there and you have the editor plugins, you'll see that the editor is actually adding some of these comments here. So these comments I can't actually select. The editor is adding them dynamically. So if I come in over here, I'm gonna remove this center widget. You'll see that comment was automatically removed, which really helps, because that was a big complaint of mine is, how do I know where this thing ends? It's really hard to manipulate this code and wrap things and unwrap things. But the editors have really gone out of their editor plugins have come a long way in making it very, very usable. I also see that there's some lines being drawn directly to the children of this column widget and whatnot. So
That's fancy.
Don't let the fact that there's no angle brackets in the code throw you off.
You said you use IntelliJ for this?
Yes, I'm using IntelliJ. The same plugins are available in VS Code, Android Studio, and WebStorm. I think there might even be some for Sublime Text and Atom, but I'm not totally sure.
Cool.
Any other questions? How's VS Code? Of course, Tom would ask that. I have not tried it, even though I have the editor plugin installed. As far as I understand, it has basically all the same functionality, maybe a slightly different form. It doesn't have all the fancy UI that I was showing to see all my connected devices and run the app on those devices, but it at least has commands to run all that same stuff. And all of the stuff that I'm doing in the UI is also available on the CLI. So I can write Flutter run on the CLI, and I'll get it back, or it'll run on a connected device. Why did I abandon my love for VS Code? Because IntelliJ is better. Sorry. Sorry, not sorry. Okay. Well, yeah, join us next month, and we'll dive into a lot more advanced stuff. I'll probably pull out some examples from the method conf app that we put together. We'll dive into some more advanced styling things, and you can see just kind of how customizable this UI is. Even though we're dealing with material design stuff here, your app does not have to look material design in any form or fashion. We'll also dive into network access. What does it look like to make some API requests, and then also just how to manage state on an app level. When you have a lot of little bits and pieces you're trying to hang on to. So that'll be next month.
Can't even wait. This session will be recorded, hopefully. We set the recording, so we'll post up to YouTube and
Got on Zoom.
y'all
I thought about it.
there it is.